I'm Tom from TC Tiny. I'm here at Ecos, my workplace, and I'm just gonna do a very long and detailed explanation of what is behind me, which is known to me as the book bunker. It's been commissioned by an author who has a very valuable book collection in a fire-prone area, and we don't want that to get damaged under any circumstances, whether that's from tree fall, fire, smoke, wind. All of these could make some real damage into that very valuable book collection. So behind me, it's 4.8 meters long. It's 2.4 wide, so it fits on the back of a truck. It's on skids, it's not on wheels, so it's not my usual my go-to construction, which is a tiny house on wheels. It's extremely resistant to fire, above that of a flame zone bushfire construction. It has no services whatsoever, so that removes a lot of the weak points. There's just a single door and a window. The window definitely opens, so you can get some ventilation in there. But mostly this is a reading nook and a storage facility. So it's not for nighttime use. There's no lighting in there, and no solar on the roof. And that allowed me to go to a really high level of fireproofing, and not just fire, but disaster in general. So I'm going to take you through the materials and the techniques, and through to the interior as well to see how I've done it up. So the first thing that people think of when they see fireproofing is the cladding. Here I've used a magnesium board oxide. It's what I use now, pretty much standard on tiny houses. It's a sheet cladding, so it's pretty easy to install, and it does not conduct heat. What I can tell you about the cladding board is that it's not the most important component, and in fact it's actually the last bit that matters. What I'm really looking for in a cladding is something that firstly doesn't conduct heat, and secondly stays stable under heat. So that's why we're not using steel. Steel's going to make a terrible mess of things when it gets hot and starts to crumble. We're also sort of looking for something which adds to the bracing component and that doesn't capitulate if it gets struck by something. So impact is a huge part of what I'm working on here. So this magnesium board has a gauze in it which holds it together. It's an aerated masonry product, so it doesn't conduct heat, and it's all connected to a timber structure. So here's the wall panel. We've got magnesium board on the outside, fixed every 100 millimeters with roofing screws. It's connected to a 35 by 45 timber batten. The batten's been coated in incandescent paint, so that should the cladding be damaged, the frame itself is actually fire resistant. The inner board, insulation board here, is a mineral wool, which is extremely fire resistant, and you can see this entire system has been tested on a bonfire. You can find that on my channel. I'll link it in the description. But basically this construction is fire resistant without the cladding on the outside. It simply wouldn't be weatherproof. Behind the exterior batten setup is this plyboard. It's 15 mil. It's through the entire house. So every part of the house is basically two walls. And on the inner wall, we've got 90 by 35 studs, rafters and joists. And inside that, earth wall insulation, which is not combustible. It's not necessarily fire resistant on itself. And then the inner wall is a 7mm pine ply. Even that has an insulative property, which is not to be dismissed completely. So that wall construction is used on the roof, on the joist, on the floor joist, and on all the walls. I've lent them inwards, and you can see this angle here. It's a 12.5 degree inward camber. That does a few things. It can deflect heat that's coming towards it. It also creates, with more corners, it creates strength. I don't find it loses too much space on the inside, and we'll see the shelving setup in a minute. And it also reduces the span of the rafters. And by doing that, we're creating more of a point for the event of a tree falling on it or a large branch. So we're trying to deflect heat and debris away from it. Behind me you can see the paintwork here, if I can get out of the sun. The paintwork here is blue and black. It's a mottled paint colour, It allows, firstly, for some weathering, doesn't look out of place, gives it an old-fashioned feel. I can't make it look brand new from the beginning for too long, so I basically take the approach of making it look old from the outset. So I've fixed the cladding to the batten at every 100 millimeters. It doesn't need to be fixed necessarily that much, but I do find it helps. Firstly, it gives me the appearance that I'm looking for, but also should the board be damaged, it gives it a large degree of stability, even when something's been maybe pierced the board with a piece of debris that's flying through the air. These strips here are steel. The key with steel is that it is purely on the outside. There's no thermal bridges. It's not going through to the interior at all. It's simply covering the join in the board. With any steel, it expands a lot under heat. So what we want to do is make sure it's got a little bit of a gap wherever it's exposed to a lot of radiant heat. The backside of this building isn't. It's actually facing an earthy cut, but the front side is. It's potentially facing an enormous amount of radiant heat during a fire. So there I've given all the steel room to expand. I've just finished the steel short by a couple of millimeters so that it can move. I've also given all the screws clearance holes. So it's a 7mm clearance hole with just a 3mm shaft on the screw, and combined with the 12mm thick magnesium board, it allows the screw just to move a little bit so it doesn't snap during a fire. All the long runs of steel that go full length are cut and either overlapped or at least given a gap where they can expand into in the center as well, so then all the expansion goes into just at the ends. So behind the steel strips, the magnesium board has already been corked up with intumescent cork, so it's completely fire resistant before those strips went on. Once I put them on, silicon down the inside. It's heat resistant silicon that I've used all over. That's with the glazing, the doors, filling gaps, and sealing up these strips here as well. It's heat resistant. It keeps it sealed up to 300 degrees and then resistant up to 600 degrees past that. Of course, fires get hotter than that, which is why behind it, intumescent cork, magnesium board, the whole lot is sealed, and we're not relying on the steel or the silicon. Right on the top of these pipes, there's the whole lot is siliconed in. That's for waterproofing. The magnesium board is fine until you drill through it. So we do have to be careful that once something's been drilled into, that we are sealing up correctly around the outside of it. These bars here are Tiedowns. They are obviously serving an aesthetic purpose, but they're also pinning it down to the ground. The winds in fires can exceed Category 2 tornadoes. So we're looking for something that can't be moved around, something that can't be flipped over. And while it does seem highly unlikely, the weight of this is about 3.5 tonne, and given its shape, it's not going to attract a lot of wind. But it's a small measure for a lot of peace of mind. So that'll be bolted down into some concrete blocks into the ground and pinned to a few boulders. The pipework behind me is almost completely aesthetic. It is serving a purpose as a ladder to get onto the roof. And it is quite a glorious view from up there. A beautiful place to read a book from if that's your thing. Not expected to get a lot of use. It's adding a lot from my perspective to the aesthetic of the building from the front. So here we're looking at the roof. The roof appears to be checker plate steel, and it absolutely is. It's 2.4mm checker plate, but underneath that is the magnesium board. So it's completely sealed in from fire with magnesium board prior to the steel going on. That's because I don't trust steel. It's going to expand, it could snap screws, it can pop and twist upwards. To allow that to happen, you can see the joint strips here. Underneath that, there's a 10mm gap between the checker plate, and that's true of the top as well. So it has room to expand in all 4 directions, so it doesn't snap the screws. The steel capping is a 6mm by 100 flat bar. It's welded down the center, and that's the entire unit is welded together. That's giving it protection from tree fall. Exactly what that would do under heat, it's probably going to snap a few screws. It's so strong that it's not going to fly away. The screws are 65mm roof screws, there's a lot of them, and they get a lot of clearance on those screws to allow a bit of movement. But that's there to stop something from piercing right down through the center. the steel checker plate plus the magnesium board plus the ridge cap is all providing protection from a falling tree, falling object, falling branch. And the shape itself, I mentioned the short spans. It's basically sort of built towards a bit of a spear point. Just the hip roof too is a bit of a feature that's removing the length of the ridge beam, just reducing that length and adding a lot of strength and rigidity to the object, especially because it is going to be towed around. It's on skids, it's not on wheels, so it's not going to get a gentle life in its the way that it gets moved around. The roof has no gutters. Again, that's increasing the fire resistance. Gutters are a weak point that this house simply doesn't have. In lieu of a gutter though, we do have a simple strip along the top. It's just deflecting the water so that it doesn't land on top of the doorway. Along both the doors and the windows, we have just a simple strip, which is just deflecting water over the top of the shutter. The window itself is definitely water resistant, but we do want to deflect that over the top of the shutter so it doesn't all flow down behind the shutter. The door itself is always a feature of anything that's fireproof. This one here is no exception. It's missing currently. It's 42mm thick triple glazed unit. The glazing is argon filled and it's 6mm toughened on the outsides and 4mm toughened on the interior. It's fixed extremely strongly with 3 heavy duty hinges and as well as 3 points on the closing side as well. We're looking to remove all the thermal bridges, so I've got ironbark timber. It's steel on the outside, there are steel components within it, but there's no thermal bridge going through the centre other than the spindle that goes through this latch. It's a industrial grade metal latch. There's no plastic in it whatsoever, and that prevents it from melting and jamming closed in a fire. I said it's pinned 3 points on each side. Top and bottom, we have these bolts. They're not closing into a lot, but what they're doing is stopping the door from having any kind of warp, both due to weather and heat. So should the heat hit this during a fire, it's got steel on the outside, so it could warp. We don't want that because even just a couple of millimeters of movement would make the seal on the inside not smoke proof, and smoke is definitely a big enemy. Smoke can last for days and even weeks during bushfires. We can see that this is a smoke strip. It's silicon, which is rated up to 600 degrees. It is fixed to an aluminium strip, so 360 if we're serious. But it's on the inside of the shutter, it's on the inside of the door. So it's the third lip back from the third form of defense. It's got a triple strip, which is going to do its best to stop heat and smoke from coming in over a long period of time, as well as embers. I can't run that silicon strip all the way around. It doesn't work on the bottom. So instead, I've got this strip here. Again, it's rated for an industrial fire. And it's got a small silicon strip which pops down when you close the door and seals it tight on all 4 sides. On the outside of the door, there's a second lip. It's this one here. It's this steel lip. It's 3mm steel. And that's going to close against that ironbark jamb. This is our shutter. It's got steel checker plate on the back side, on the outside of it. And then that's mounted onto magnesium board and ironbark timber. The ironbark timber and spotted gum here is going to stay stable under heat. The magnesium board is going to stop the heat transfer through to the interior. And the steel is going to provide a barrier from flame, embers, and impact as well. As always, extremely strong, and I can close it just with one hand. That's my unofficial test for whether everyone can use this or not. If I can do it with one hand, most people should be able to do it with 2. So here in the blinding sun is our window, and it's fixed with slide bolts, again, steel slide bolts. It's got latches That's for mostly for wind, to stop it from rattling around. And behind it is industrial strength window. Same glazing unit as the door, that's triple glazed, 6mm toughen on each side, 42mm thick. We've got a fold down handle. It's on gas struts, so it opens up. And on the inside, we've got bolts too that pin it to the door jamb on either side, pinning it really tightly closed against the silicon strips. Inside the window, we've got a fly screen here, which is a magnetic fly screen. So it just pins to the inside, really easy to get on and off, and that increases airflow for the people sitting inside. So we're inside the book bunker, away from the blinding and burning sun. It's quite cool inside. The shutters have done an excellent job of blocking the heat. Quite important for any small object is to be able to keep the heat out. Small houses just heat up very quickly, and this is no exception. So the interior is purely for books. We are filled with shelves. All four sides of this loaded up with Oregon shelves. This is originally Douglas fir, come from America, shipped to Australia, used in a house, pulled apart, recycled. And to use it, I've brushed it. I haven't planed it. Oregon doesn't plane very well. So I've brushed it down, gets rid of all the splinters and leaves the features. So you can actually feel not just the grain, but also all the old saw cuts in it as well. Gives a really aged feel, a lot of warmth to the interior, and mixed with some black putty and black features, it's given it that really old-fashioned feel, which is what I'm going for. The corners, even recycled timber shrinks, and in doing so, it can actually snap all its fixings. So loaded it up with some steel corners that allow for movement in the timber and allow it to stay structurally sound. It is going to get a considerable amount of weight put on it. The floor also is recycled Oregon. Board's been split in half, so it's 22mm thick. Pinned down with a lot of decking screws. It's not tongue and groove, so to make up for that, I'm putting the joist at 600 with a 300mm floating joist. So in the event of a fire, these shutters can be locked up, and they allow you to either leave early or bunker down in a much more certified person bunker, which does exist on this property. This is not a bunker for people to sit in. There's actually no possible way you could do it. The door closes from the inside, but the shutter doesn't. There's no way you can actually lock yourself in the way that would be required to survive a fire. So that's to remove temptation from anyone attempting it. There's no need to do that. This is for your belongings only, and it allows you to live in a way stress-free, knowing that your valuable book collection, art collection, your studio is going to be there when you return. I hope it can contribute to your own fireproofing techniques. It is of course fire resistant. I use fireproofing techniques to make something fire resistant. It's not just bushfire that I'm building for, it's tree falls, wind, smoke and storm can all cause a lot of distress, especially in a changing environment that we have here in Australia. I hope that's been a useful video for you. If you've got any questions, leave them in the comments below. I'll get to them eventually. And please check out other videos, burn tests that I've done, and other houses, mostly tiny houses on wheels that I've been building for a couple of years now. Thanks a lot. I'm Tom Coop. Catch you next time.